denominator. So in other words, I need to make 10p look like 20pq, and I need to make 5pq look like 20pq. So in maths, the rule, whatever you do to the denominator, you do the same to the numerator. Whatever you do to the denominator, to the bottom number, the number underneath the horizontal line, which is a division line, you do the same to the numerator. So that's what we're going to do. Right, so 12p subtract 8q plus 5 over 20pq. We're not going to touch that part because 20pq is the common denominator. So I'm going to go to my next one, the next part. I've got 4 over 10p. Now, I want that 10p to look like 20pq. So if I times 10p by 2q, that will give me 20pq. There you go, 20pq. Now remember, I only multiplied the 10p by 2q to get 20pq. Remember, that's important. I did not multiply 10pq by 2pq. I multiplied 10p by 2q to give me 20pq. So I'm going to multiply the 4, which is the numerator, by 2q. So if I multiply that by 2q, guess what I get? I get 8q. Okay, I get 8q. So now my denominator looks the same as my 20pq for the first fraction. If I go now to my last algebraic fraction on the right, I've got subtract 3p, subtract 1 over 5pq. I want the 5pq to look like 20pq. So I'm going to multiply 5pq by 4. Because if I multiply 5pq by 4, I get 20pq. And then the 3p times 4 becomes 12p. And the minus 1 times 4 becomes minus 4. So what I've got now is I've got 3 denominators that look the same. So I'm going to read it out to you. 12p, subtract 8q plus 5 over 20p, plus 8q over 20pq, subtract 12p, subtract 4 over 20pq. So my 3 denominators, they all look the same. And what I'm going to do now is I'm going to simplify. We simplify fractions in maths, don't we? So it's the same thing. So sometimes when you see certain topics and certain words, it can cause, oh my gosh, I don't know what it means, but break it up. All I'm doing is breaking it up. So I want to simplify. I want to get rid of what I do not need. So I've got 12p, subtract 12p, they cancel out. So we don't need them, they've gone. 12p take away 12p has gone. Now I've got minus 8q plus 8q. Minus 8q plus 8q, that's gone. They cancel each other out. Minus 8 plus 8 is 0. So they cancel themselves out. They've both got 8q. So what we're left with now is 5, which is positive 5, minus 4. Positive 5 minus 4. A negative and a negative give you a positive. So 5 plus 4 equals 9. So my numerator is 9. My denominator is 20pq. And that is the correct answer. So that was what we call algebraic fractions, okay? It's not anything to worry about. If you break it up into parts, the algebra part and the fraction part, and you follow the same strategy, method, and procedure for adding and subtracting fractions, you will get the correct answer. Okay, you're going to get the correct answer. And this is what makes math so special. And this is why I enjoy the math show. Right, okay. Exact trigonometric values. Sine, cosine, and tangent. Okay, for GCSE higher tier, non-calculator paper, you need to know the values for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees without a calculator. For example, sine of 30 degrees, I know, is equivalent to a half, 0.5, okay? How do I know? Because I've been doing it for years and years, and I've been teaching it for years and years. And the way I'm going to teach you now is actually quite exciting. And you're going to say to yourself, oh my gosh, I didn't know it was so easy. So, right, remember at the top of the piece of paper, can you write 0 degrees, have a little gap, 30 degrees, have a little gap, 45 degrees, have a little gap, 60 degrees, have a little gap, and 90 degrees. Okay, so you've got 0, 30, 45, 60, and 90 degrees. And I'm going to show you how to find the exact trigonometric values for sine of 0 degrees, sine of 30 degrees, sine of 45 degrees, sine of 60 degrees, and sine of 90 degrees. You need to know the same for cosine and tangent, but I'm just aware of the time. So I just want to make sure that I show you what to do, and then you can then take it away, and then you can make use of it, and then you can understand what to do. But remember, I've always said to you that do not try and learn something. Do not try and learn something now, okay? There's no need, okay? Because it's too late. And I don't want to cause panic. I don't want you to start worrying what happens if, and so on. So let's work out sine of 0 degrees. So you've got 0, because remember I said 0. So 0. Now, when we are doing this, I want you to write, so you've got 0 degrees. Underneath 0 degrees, can you put 0? Underneath 30 degrees, can you write 1? Underneath 45 degrees, can you write 2? Underneath 60 degrees, can you write 3? And underneath 90 degrees, can you write 4? So you've got 0 degrees, 30, 45, 60, and 90. Under 0 degrees, you've got 0. Underneath 30, you've got 1. Underneath 45, you've got 2. Underneath 60, you've got 3. And underneath 90, you've got 4. Now, can you put the square root sign over the 0, the square root sign over the 1, the square root sign over the 2, the square root sign over the 3, and the square root sign over the 4. So on your piece of paper, what you should have is 0 degrees. And then on the left-hand side, you've got sine. We're looking, this is to do with sine values. And then you've got 0 degrees, and then you've got 0, root 0, you've got root 1, root 2, root 3, and root 4. Now, underneath root 0, can you write 2? Underneath root 1, can you write 2? Underneath root 2, can you write 2? Underneath root 3, can you write 2? And underneath 4, can you write root 2? Now, that's quite straightforward, yeah? So, sine of 0 degrees, you've got root 0 over 2, and that equals 0. So, sine of 0 is 0. Sine of 30 degrees, you've got root 1 over 2, and that equals a half. Sine of 45 degrees, you've got root 2 over 2, which is the same, so you don't touch it. Sine of 60 degrees, you've got root 3 over 2. You don't touch that either, it's the same. And then sine of 90 degrees, you've got root 4 over 2, which is simplified to 2 over 2, which is equal to 1. So these are your trigonometric values. They are the exact values for sine of 0 degrees, 0. Sine of 30 degrees is a half. Sine of 45 degrees, we don't change, 2 over 2. Sine of 60 degrees, we don't change, root 3 over 2. And sine of 90 degrees is root 4 over 2, which is simplified to 1. So these are your exact values. Now, if you put into your calculator root 0 divided by 2, you're going to get 0. If you put into your calculator root 1 divided by 2, you're going to get a half. If you put into your calculator root 2 divided by 2, it's going to be the same. If you put into your calculator root 3 divided by 2, it's going to be the same. And if you put into your calculator root 4 over 2, it's going to be equal to 1. So what I've just taught you is a lovely way of being able to recall your exact trigonometric values for sine of 0 degrees, sine of 30 degrees, sine of 45 degrees, sine of 60 degrees, and sine of 90 degrees. So, wow, what have I given you this afternoon so far? Do you know what? It has been amazing. Okay? It has been absolutely amazing. And what I want to say to you is this, yeah? If you are making notes on the show, you are going to feel even more confident than you already feel. I'm telling you, okay? Today's show is about confidence. It is not about teaching a new topic from scratch. That's too late because tomorrow is the exam. And if you start to learn something new, it means what you have learned already, you're going to push to one side, and that's what you need to be revising. And please do not go to bed late tonight. Do not go to bed late because you need to have a fresh mind in the morning. You wake up, get yourself to school on time, and then enjoy the exam. I know it sounds easy. How can you enjoy a math GCSE exam? You can and you will because you will know what to do. And this is the whole part of today's show. Okay, it's really important. So we looked at algebraic fractions. You know what to do with algebraic fractions. I've given you my prediction. Can I also give you some advice to do with a the quadratic formulas, yeah, quadratic equations? There are 5 methods to solve a quadratic equation. Please make sure you know all of the 5 ways. You can solve quadratic equations by factorizing. You can solve quadratic equations by using the quadratic formula, which is minus b plus or minus square root b squared subtract 4ac divided by 2ac. I still remember, if I'm teaching it, I've got to know it as well. You can solve quadratic equations by completing the square, very exciting. You can solve quadratic equations graphically, and you can solve quadratic equations using the calculator. But remember, tomorrow's paper is non-calculator. So they wouldn't give you a question where you need to use the calculator because it's a non-calculator paper. So just to make, this is just advice on making sure that you are ready and that you are prepared. Okay, we're going to go for a short ad break. I've been talking and I can feel, I've had a couple of messages on the phone that, you know, there's students out there who clearly want to do well, and they're asking me, Mr. Numbervator, I've learned this, is it okay? Yes, whatever your school has taught you, whatever your teacher has taught you, whatever your mum, dad, family member has taught you, whatever I've taught you, stick to that. And that's what you need to know. You know enough, year 11s. Don't doubt yourselves. Have confidence in yourselves because I know that you are going to be absolutely brilliant. We're going to go for a short ad break. And then when we come back, I'm going to go into part 2 of the show and talk to you about quadratic sequences and then go through some questions that I've got written down just to give you that added confidence, that added knowledge. If you're watching live, you can see that I'm smiling. Why? Because maths is really beautiful and it's such a lovely subject. It's a pure subject and there's no need to worry about not knowing something. If you don't know something, you don't know it. We in the real world, we do not know everything. I do not know everything. I am still learning. I make mistakes. I get things wrong. That is what being alive is all about. But wanting to correct and wanting to learn and know, that is what makes you special. So don't worry. Have an early night. You wake up, you go and sit your exam. And I know I'm going to get phone calls. Mr. Numbervator, it was really easy. Thank you. And that's what it's all about. So we'll come back after the short ad break and I'll see you soon.
successful career.
Apply today at cnwl.ac.uk.
The College of North West London, where your future begins. Tokyo Radio.
Go to www.sovereigncomics.co.uk and get your latest issue of Mr. Numbervator's Maths comic book series today. You are now tuned into the Mr. Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station. Let's get mathematical.
Welcome back to part 2 of the Math Show with me, Mr. Numbervator, on Chalk Hill Community Radio Station. And it's Wednesday, and every Wednesday, each and every Wednesday, between the hour of 5:30 and 6:30, it's me in the hot chair, and it's the Math Show. Very interesting. I mentioned something at the beginning of the show about yesterday being International Women in Maths Day. And I've had a message that's come onto my phone, and there was a mother, it's a mother of a daughter, and she was saying that she didn't know about International Women in Maths Day, but she was saying thank you to me for mentioning it and raising it. And you know, this is one of the benefits of the Math Show. This is the reason why I enjoy the Math Show, because the Math Show is about the community. It's about reaching out into the community. It's about making sure that everyone in the community knows about what's going on, and everyone in the community is kept up to date with what's going on. But more importantly, it's about sharing good practice and sharing ideas, and just making sure that that everyone is there. Now, one of my dear friends and colleagues, one of my friends and colleagues is Helena Mullins, and it was Helena, and she's the CEO of Maths Makers, and they're a lovely, brilliant organization who are supporting young people, children in schools. And it was Helena who brought my attention to International Women in Maths Day. And this is what I mean by the connection. Helena has passed information on to me, and I've passed information on to you listening on the radio. And this is how I want it to be. So Helena, thank you very much for giving me that information. And just to make sure that everyone has got the right information, yesterday was International Women in Maths Day. We want more girls and women to get into maths. In Ghana, when I was there last, we were looking at how to get women into engineering. And there's a big push to get young women and girls into engineering in Ghana. And it's growing. And if we can do it in Ghana, we can do it here. So let's get many hundreds, thousands of women and girls studying maths, taking maths seriously, enjoying maths, and there's no need to lack confidence. As I said earlier, what you don't know, you'll be taught. And if you don't know something, you can always find out. Okay? So girls, women, we want you to get into maths, learning maths, and continuing learning maths right up to A level and beyond. Why not? That would be absolutely amazing. Why not? So yesterday, International Women's Day. Thank you, Helena, from Maths Makers. My prediction for tomorrow's paper 1, quadratic sequences, quadratic equations using factorizing and the formula minus b plus or minus square root b squared minus 4ac divided by 2a. The nth term, using trigonometry to find the sides and the angles of the right angled triangle, algebraic fractions, which we went through at the beginning of the show, and using Venn diagrams with set notation. Right, so I have covered already quadratic sequences in one of my shows. So I just want to briefly just run through what you have to do. Now, remember, I'm not teaching it, because what I don't want to do is people start worrying and panicking. Oh, I can't do it. I haven't done it. No, it's too late now. What you need to do is revise what you know, master what you know. That will get you through. I'm telling you, that will get you through. You know enough. Year 11s, you're one of my favorite year groups because you did have it tough during the pandemic. There were a lot of lessons that you missed out on. There was a lot of one-to-one teaching that you missed out on. But look at you now. Just look how far you've come from those days to today. And I know that you are going to walk it. You will enjoy tomorrow's paper. Yeah, it's non-calculator, but you will enjoy it. And once we've finished with our paper 1, we're going to look at paper 2, and I'm going to be getting you ready for paper 2 and beyond. So quadratic sequences. Now, quadratic sequences, there's a formula that they follow. I'm going to read it out to you, but I'm not going to go into the how and the why. I'm going to be explaining to you how to solve and answer a quadratic sequence question, okay? So the formula that we use is we can have an squared plus bn plus c. That's it. Or the one that you know for quadratic equations is ax squared plus bx plus c equals 0. It's the same thing, okay? It's exactly the same thing, but with the quadratic sequence, because we're linking it to the nth term. Can you see the reason why it's not ax squared now? It's an squared plus bn plus c. So I've made up a sequence. I'm going to run through how I solved this question using my knowledge and understanding of quadratic sequences. So the 5 numbers are 10, 21, 38, 61, and 90. So I'm going to repeat those numbers. 10, have a gap. 21, have a gap. 38, have a gap. 61, have a gap. And 90. Okay? Now, what we're going to look for first is our first difference. We're going to look for our first term-to-term difference. Remember, 10, 21, 38, 61, and 90, we do not call them numbers, we call them terms. When we're looking at sequences, they are called terms. So my first term is 10, my second term is 21, my third term is 38, my fourth term is 61, and my fifth term is 90. I did not say my first number is 10, my second number is 21. They are called terms. So the term-to-term rule for the 5 numbers that I have just said, the difference between 10 and 21 is add 11. The difference between 21 and 38 is plus 17. The difference between 38 and 61 is add 23. And the difference between 61 and 90 is add 29. So my first difference is plus 11, plus 17, plus 23, plus 29. Now that I've got my first difference, I am now going to work out my second difference. So now I'm using 11, 17, 23, and 29. The difference between 11 and 17 is 6. The difference between 17 and 23 is 6. And the difference between 23 and 29 is also 6. So now I've got my second difference of 6. I am now going to halve my second difference. I'm now going to halve my second difference. Because I've got 6 all the way, I'm going to halve 6, and that will give me 3. So the first part of my quadratic equation from my sequence is 3n squared. You remember I said to you an squared plus bn plus c? Now we've got the first part, which is 3n squared. So now we're going to work out the second part of the equation. So what I'm going to do is I'm going to rewrite my first original sequence, which was 10, 21, 38, 61, and 90. Now above the number 10, I'm going to write 1 and put a circle around it because 10 is my first term. Above 21, I'm going to put a 2 and a little circle around it because 2 is my second term. Above 38, I'm going to put a little 3 and put a little circle around it because 38 is my third term. Above 61, I'm going to put a little 4 and a little circle around it because 61 is my fourth term. And above 90, I'm going to put a little 5 and a little circle around it because 90 is my fifth term. Now, I want to get the next part of my equation, which is the Bn part, yeah? So what I'm going to do is, remember I've got 3n squared. N is the number of the term in the sequence. N refers to the number of the term in my sequence. So what I am going to do is 3 multiplied by 1 squared is 3, because 1 squared is 1 and 3 times 1 is 3. So underneath the number 10, I'm going to write subtract 3. 21, the next term, 3n squared. So 2 is my second term. So I'm going to do 3 times 2 squared, and 2 squared is 4, and 3 times 4 is 12. So I'm going to be subtracting 12 from 21. My next third term, 3 times, so 3 squared is 9, and 3 times 9 is 27. So I'm going to be subtracting 27 from 38. Fourth term is 61. 4 squared is 16. 3 times 16 is 48. So I'm going to be subtracting 48 from 61. And then my last term, number 5. 5 squared is 25. 3 times 25 is 75. And I will be subtracting 75 from 90. I've slowed down my talking because I know that there's a couple of you're making notes as I'm talking. So I want to make sure that you've got the notes. So 10 subtract 3 is 7. 21 subtract 12 is 9. 38 subtract 27 is 11. 61 subtract 48 is 13. And 75 subtract 15 is 90 subtract 75 is 15. Okay, so now I've got like another linear sequence there, not 7, 9, 11, 13, and 15. So I'm going to look for my second difference again, which is 2. The difference between 7 and 9 is 2, 9 and 11 is 2, 11 and 13 is 2, 11 and 13 and 15 is 2. So the next part of my equation is 3n squared plus 2n. Now we want to get the last part. How do I get from 2 to 7? I'm adding 5. So my equation is 3n squared plus 2n plus 5. I've solved it. Okay, so that is how we solve quadratic sequences. Okay, remember, I'm not teaching this from you, okay, because you already know what to do. And what I do not want to do is cause any worry or anxiety about, oh, what do I do? I don't know this topic. I've got to go and learn it. No, please don't run away and learn something new from scratch. You're meant to revise what you already know. And I'm sure that all of what I'm talking about, you've been taught it. And so all I am doing is I am refreshing your memory. So that's what my role is this evening. Okay, so some advice again. Please remember that a cube has got 6 faces. And, you know, sometimes there's questions with, you know, if the cube's got 6 faces and the total is 150, you're going to divide by 6 to get 25. So each face has an area of 25 centimeters cubed, which means each side length is 5. So to work out the volume, it's 5 times 5 times 5, length times width times depth, which is height. And then you get your answer of 125 centimeters cubed. Frequency and midpoints and frequency density, histograms. Please remember how to get the midpoint. You know, you look at your first range. So my first range could be 0, less than or equal to R, which is rainfall, less than 5. So the difference between 0 and 5 is 5. You divide by 2. So the first midpoint would be 2.5, and so on and so on. Please remember set notation using the Venn diagram. Please remember all of your correlations. So as one axis increases, so does the other. So that is positive correlation. You've got negative correlation, and you've got 0 or no correlation. Remember, when you're working out percentages of amounts, volume of a cylinder. Volume of a cylinder is area of the cross section times the length, which is the height. The bottom of a cylinder. So imagine a tin of baked beans. You've got the base of the baked beans is a circle, so that's to do with pi r squared, and then the height of the tin is basically the length of the side, which is what you multiply that by, and then that gives you the volume of the cylinder. Pressure is equal to force divided by area. Remember, angles in a quadrilateral, that they add to 360. How do you find out the angles, the interior angles in a polygon, exterior angles and interior angles? Don't forget probability. When you're looking at simultaneous equations, all of your angle theorems, all of these are what you need to know. And because I want you to do your best, that's why I'm going through all of these this evening. Please remember your nth term rule. Remember compound interest, your compound interest formula. Please also remember, when you're doing your histograms, your intervals, your midpoint, and your commutative frequency, speed, distance over time, your simultaneous equations, how to expand triple brackets and double brackets. What does the word reciprocal mean? It means 1 over a number. So that's quite straightforward. Remember your fractions and ratio. And yeah, that is it. I think I've gone through everything that I think is going to come up tomorrow. Now, of course, there's going to be more. Of course, there's going to be topics that I haven't covered or I haven't mentioned. But that's because I know that you can do it. That's because I know that you can do it. So my year 11s, I'm referring to you as my year 11s because you're special, because you've done so well, and I'm just really proud of you, year 11. You've had it tough throughout your learning when it was the pandemic, and you kept on going. Your parents and family supported you, supported the school. A lot of your work was online, so you didn't have access to that one-to-one face-to-face teaching. But look at you now. You are going to do well. You will be successful, and you will enjoy tomorrow. I'm wishing you all the best for tomorrow. Maths GCSE Paper 1, whether you're doing higher tier or foundation, I wish you all the very, very best. It'll be interesting when you open your paper, if you have got quadratic sequences or using factorizing and a formula to solve quadratic equations, the nth term, trigonometry, algebraic fractions, and set notation with Venn diagrams. Get an early night's sleep so you're nice and fresh for the morning. Have a great exam, and send me a message 07535 644 850. Send me a message. Let me know how you get on, and then next week we will start to look at the other papers and preparing you and getting ready for that. Have a great afternoon, a great evening. The sun is shining, and that means it's going to be a good night, and it's going to be a good day tomorrow for all of my year 11s. All the best, and I shall see you next week on the Math Show with me, Mr. Numbervator, on Chalk Hill Community Radio Station, where we believe in keeping the community connected. Have a great evening. Thank you and bye-bye.
Hey Londoners, are you ready to start your next educational adventure?
Welcome to City of Westminster College, where learning is anything but ordinary.
Maths comic book series today. Go to www.sovereigncomics.co.uk and get your latest issue of Mr. Numbervator's Maths comic book series today. You are now tuned into the Mr. Numbervator show every Wednesday from 5:30 to 6:30 p.m. on Chalk Hill Community Radio Station.